Hello, everyone. So, what is strange, Reem and Raida, what is strange is we are working together, four of us, Jamaica, Matt, Joel, and me. Right, little while back, there was a fifth person on the Zoom call, but the five of us are sitting in 5 different locations. 5 different locations. This is the wonder of modern technology. Matt is sitting on a mountaintop in Hawaii. Jamaica is at sea level in Hawaii. Joel's in Canada. Elisa and I are in California.
It's Joe in Canada.
Joel is in Canada. Yes.
Raise your hand. Okay, Hada, Joe in Canada.
Joel is in Canada. Yes. Matt is on a mountaintop in Hawaii. There we go.
Hawaii.
Jamaica is at sea level in Hawaii.
Sea level.
هذول من جامايكا ومستوى سطح البحر. هذا من كندا. Okay.
Yes. I'm in California.
واللي معنا من كاليفورنيا.
You can see the ocean behind me.
Is it really?
It's a picture I took of the ocean.
Yeah,
Yes.
I know. Okay, it's a picture.
Not a it's a
Something's coming out.
it's a virtual background. Yes, it's a virtual
Okay,
background.
هيك عشان يشوفوكوا أكثر.
Actually, it was a sunset. Picture of a sunset. Hello.
أنا بلغيك.
كمان شوي.
This is great. This is so nice. What is the name of your school? Neve Shalom School?
واحد السلام. We usually start with the word. We usually start with the word واحد السلام in Arabic and then say Nave Shalom in
Right.
Hebrew.
Wahat al-Salam
Wahat.
means oasis of peace.
Oasis of peace.
Yes.
لا. قالكم قال إنه أنا جيت زيارة شهرين عن واحد.
So I have been to your village twice.
مرتين أجل. Okay.
Raida, were you able to share the Zoom link with the mother of the boy?
I sent it to her. I hope she will join soon.
Okay.
It's okay. We can start whenever they.
Okay.
join,
I'm going
they
to
can-
share some pictures of the night sky, and then some pictures of stars and galaxies. Okay. This is a question. This is a question for Reem's classroom. What is your favorite star? What's the name of your favorite star? Taylor Swift, the sun, Justin Bieber.
ايش كوكبهم المفضل؟
They say Mars.
They say Mars. That's very good. Okay. Mars is a planet, but what is the nearest star to us? The sun. Very good. So what you will see now is a picture of not our sun, but another sun, another star that's very far away from us.
مش الشمس تبعتنا شمس ثانية.
Okay, very far from us. Jamaica, just a quick question. This is recording to the cloud. Is that okay? Or should I stop and record to my computer?
Oh, no, cloud is good. Cloud is
Cloud
good.
is okay. All right.
Mhm.
All right. Okay, so I'm going to show you a picture. I'm going to share my screen for this and show you a picture of some stars. Not one, but many stars. Let me see. There we go. Do you see my screen?
Yes. هدول كلها نجوم ما موجودة. They're galaxies or stars?
These are galaxies. Where you see my cursor, this is a galaxy. But this
Very
one is a
far-
star. With
Yeah.
the straight line, vertical line, that's a star. That's a bright star.
هدول مجرات وهدول نجوم. هاي نجمة اللي عليها خط.
Okay. Every time you see this vertical line like this, you see a vertical line here, vertical line here, one over here. Each of these is a star.
لما بحط خط زي هيك
This one is a star.
هذا نجم زي خط.
But there's something funny about the vertical line. It's not really a vertical line. What happens is the vertical line is caused by the silicon detector.
Which is?
So this is a digital camera. Yeah, sorry, go ahead, go ahead.
Again?
Yeah, so the picture is taken with a digital camera.
Yes.
And digital camera have this problem in them. That is, if you put too much light in one location, that light, not the light, but the charge it creates, the electrons it creates, start to overflow along a column, up and down. That's what you're seeing here.
شايفين هذا الخط؟ خط هذا لأنه الكاميرات اليوم في بالفترة ما بيعملوا إضاءة بإمرار الإضاءة هاي بتسبب وجود هذا الخطوط. هاي الخط العمودي.
This is a good example. I put it in the middle. This one.
Yes. Hi. But the round ones, the real bright ones, are galaxies, can I say?
This one is a galaxy, yes.
Yeah. هاي مجرة. And it's very far from us, right? Very,
50
very far.
50 million light years.
50 million light
Matt
years.
calculated how many kilometers?
Yeah, that's
Yeah,
amazing.
four times 10 to the 20 kilometers.
4 with 20 zeros kilometers.
و20 صفر بعدها عنا. هاي مجرة. هدول نجوم. They're asking what's its name. Do you know? Does it have a name?
There are so many galaxies
No.
that we can't name them. Look at how many galaxies there are.
But they don't all of them have names.
They have numbers, not names. There are too
They
many
have
to.
numbers.
They have
عليهم
numbers.
أرقام. عليهم مش أسماء. ما بنلحق إنهاي ما التروئيس goal. They're asking why the purple color. It's not purple rain.
Purple. No, not purple rain. Which purple color?
They
Let's see.
said that they see no, there's the red light. We see red
Yeah,
light.
okay.
These
So-
are stars. Now these are stars now.
These are
Huh?
stars. And in
Solar
fact,
nebula.
this thing that looks like a circle around it is caused by stray reflections in the
Okay.
telescope. The
Stray?
star is so bright that in addition to forming the main image, which is this bright dot in the center, you get many other secondary reflections. So the light bounces off the primary mirror, then hits a second mirror, bounces back to the primary mirror. So you get these are called ghosts. And
Ghosts from the word
ghosts.
ghost.
yeah, the word ghost, because a ghost is
Ghost.
something that's not real, but
Ah.
it is these are stray light. You see this sometimes if you take a bright light and you try to see it through a camera or phone, you see it produces all kinds of funny effects because the light is bouncing off many ways. And this is something like that. These are ghosts.
هدول هاي الهلال زي الدوائر حوالي كل نجمة. هدول بيكونوا من كثر ما النجم صافي من كثر ما بيسطع بيعكس الضوء بيرجع على الكاميرا بيرجع للنجم. شو بيعمل بالآخر؟ بيعمل داير ما يدور زي حلقة حوالين النجم. هدول بسموهم اشباح. هذا اشي يعني شبح، ليش؟ لانه مش حقيقي، مش حقيقي. ده لو امريكي زي كيلو ايش؟ هاي مجرة، طلع هاي مجرة، هاي مجرة، هدول نجوم. لا. They're asking if we can get closer to the galaxies.
Of
A
course.
closer picture.
Of course, I'll show you a very special one. Now,
Yeah,
let me see. Let me do that.
طلع ما احلى هلا بيقرب على مجرة.
I like this galaxy a lot. We will zoom into this one.
طلع قديش قراب، بس بيكون البعد احنا هون شايفينها بكره، بس هي كثير بعيدة عن بعضهم. Okay.
This is a very strange galaxy because it is being distorted in the same way that we were saying this to the other group I was saying this to the other group last time, that if you're driving a car and you hold a piece of paper in your hand and hold it outside the window, the paper will get blown back.
The car.
Yeah, I mean, if you're holding onto the paper, it will still form a funny shape. It won't be flat. And that's what's happening to this galaxy. It is traveling very rapidly, not through air, but through what's called ionized gas, electrons and protons that are living in this region of space.
الإلكترونات والبروتينات، البروتون في ذرات، الشحنات هاي، هذا الجالكسي شكله غريب جدا، لأنه إيش بيعمل؟ بيعمل وكأنه شكله مشوه. فكيف لما تحملوا ورقة من الشباك تحاولوا تلموها برا بترجع بقلب السيارة. بدي أصور. They're asking about the black holes.
There are black holes at the center. There is a black hole at the center of this galaxy. There's a black hole at the center of this.
Where is it? Can you show us where it is?
So we can't see the black hole directly, but we can see that it's caused a concentration of stars at the center. One of the biggest black holes we know about, one of the biggest ones in the nearby universe, is at the center of this galaxy right here. This is called Messier 87, which is one of the...
That's MS87?
M87, just M87.
M87. Where's the black, how do we see a black hole? We don't see it, do we?
You can't see it because it is, first of all, from the region around a black hole, no light can escape. So the black hole doesn't emit light from its very center, but from the region around it, a lot of light can be gathered there. This is what this black hole has done. It's gathered a lot of stars around it. And in fact, you can see this. Again, ignore this vertical streak that's produced by the silicon detector. It's actually coming from the upper star here. But can you see this little thing on the lower right at 4 o'clock?
Yes.
That is actually produced by the black hole. Yeah.
Sorry to interrupt. Matt, can I get you to meet me on the Keck Zoom, please? Sorry about that.
No problem, of course. So if you see this piece here, this is produced, do you see this where my cursor is to the lower right?
Yes.
Yeah, so this is produced by the black hole. What happens is the black hole at the center of M87 produces a disk of material that's spinning at very high speed, and some of it gets shot out like a jet, and this is the jet from M87 right here. JET, just like a jet engine or on a plane, this is a jet. High-speed jet.
How do you know if there is a black hole if you can see it?
That's a very good question. How do we know there's a black hole there if we can't see it? Black holes can be detected through their gravity. Have very intense gravitational pull, but coming from a very small region. you know that it can't be anything except a black hole.
Cool.
Very good. Very good question.
Thank you.
We'll show you an example. If you like, I can show you a picture that was taken right before the pandemic of a black hole, because black holes can bend light around the ring. It's called an Einstein ring. And I can show you a picture like that. Give me a moment. I'll bring up a picture. I'll stop sharing my screen for a minute. I'll bring up a picture of a black hole.
Raja,
Yes?
a girl here is asking, what could happen if we get into these black holes? Is there a chance that we get stuck into these black holes?
We would
And
get
what would
sucked
happen?
inside immediately, and we would not last very long. We would die almost immediately.
Oh my God. Sorry to ask this.
Sorry to answer this. But that's the truth.
Sound good.
Okay, so I am going to show you a picture of a black hole in a moment, which is the bending of light by a black hole. Okay, just a moment. I'm going to share my screen again. Okay, this is an image of a black hole right there. Oops, sorry. Right there. And you see the word says silhouette, says M87. Because light is bent by the black hole all around itself. That's why you see a ring. I'm curious why it's dark inside the classroom. It's daytime for you. Is it because you have the lights out off?
We close the shades because we have to see you. If we open them, we have too much light.
Too much sun. Okay, okay, got it.
We have too much light when we open. I'll
It is
show you.
because of the overhead projectors. We need
Oh, got you. Okay.
dark
Okay.
so that we can see you better.
Better.
If we
Okay.
put the light on, we won't see you.
Yeah, no, that makes
It's so
sense. That
light.
makes sense.
Okay.
So this is an image of a black hole. This is a very famous image of a black hole. Black holes can bend light like this.
Excuse me, Raja.
Yes,
A boy
please.
is asking, are
Yeah.
there white holes like there are black holes?
Ah, that's a very good question. Oh, by the way, I noticed that the second Raja has joined. And that
Yes,
is,
yes, he
that-
did.
yeah,
Yeah.
she can, if she wants, she can change her name by going to the 3 dots on Zoom and renaming, just so
Okay.
people are not confused. But yeah, no, so there is speculation that the material that falls into a black hole comes out in a parallel universe in a white hole.
Oh.
But that part is,
Okay.
but there's no proof of this. So why?
بس ما في إثبات. إن وخخار. Thank you. إن وخخار شيء ثقوب بيضاء. حلو. Yeah. لا فظيع بالأورالي وبالlistening. Sorry.
I am really wishing at this moment in time that I knew Arabic and Hebrew. Because it's so nice to hear your explanation, but I wish I could understand it. You know, I grew up with a lot of Urdu, which is a derivative of Arabic. So I know how to say words like Salam Alaikum. I know how to say Inshallah. I know some words, but I don't know too many words.
Okay.
You know the most important words.
Salam alaikum
Salam
is important.
alaikum is peace be on you,
Yes,
which is hello. And inshallah, if God's will.
God's willing, God willing, yes.
Yeah.
Raja, could we maybe talk about the event horizon, what we're seeing here where the light is?
Sure, sure. Please, would you like to, Jamaica, or would you like me to? What would
Oh,
you prefer?
please proceed. You go
Okay.
ahead, please.
The term black hole means something that is so small in size, but heavy in mass. So very small in size, but a lot of material, so extreme like that, so much matter in such a small space that its gravity is so strong that it can prevent light from escaping. So I do have a question for both classrooms, Raida's classroom and Reem's classroom. What is the most famous scientist name that you can think of?
أشهر عالم تعرفوه حدا بيعرف مين أشهر عالم؟
No,
One
not
boy
that.
says Raja.
No. Hopefully that's not the case.
Galileo.
Galileo, very good, very good. Any other names? Galileo is very good. Yeah.
Buzz and the astronaut Buzz.
Buzz Aldrin, very good.
Yeah,
Anyone else? Newton, very good, very good. Anyone else?
Leonardo da Vinci.
Da Vinci, very good.
Einstein.
Very good, Einstein. Okay.
Yes, Einstein.
So Einstein and Newton were both mentioned. So Newton, as you know, Newton was the first one to really explain the force of gravity, why things fall.
Yeah.
You know, when the twig of an apple breaks, why does the apple fall? Why doesn't it stay in the air? Why does it fall? So Newton really tried to understand gravity as a force between two objects, invisible force between two objects. In this case, between the earth and the apple. That's why the apple falls. And
Question for you, Raja.
No, wait.
They're asking how are black holes formed?
oh, okay. We don't completely understand all the ways in which black holes can form, but one of the ways in which they form is if you have a very massive star, very massive, much more massive than the sun, roughly 10 times more massive than the sun. During its life, is some of its outer layers, but the central part of the star, maybe half the mass is still left there, 5 times the mass of the sun is still left in the central part. What happens is it becomes so, it has so much mass that gravity starts to pull the material in, and it can collapse into a black hole. If it's massive enough, if it's more than 3 to 5 solar masses, then it can become a black hole. If it's between 1.5 and 3, it becomes something called a neutron star. And if it's less than 1.4, less than 1.44 times the mass of the sun, then it becomes something called a white dwarf. So the sun will become a white dwarf, but a star that is, let's say, twice as massive as the sun, that will become a neutron star, and something that is 10 times the mass of the sun will become a black hole. But I do, do you want to take a moment to explain that or to translate that?
I muted myself and I was translating
Yeah,
directly.
Oh, good.
I
good.
did the same.
Okay,
While
good.
muting, we translate you directly.
Good. Okay. I want to tell you a story about Einstein. So Einstein was born in Germany or lived in Germany. I think he worked in Austria for a little while as a patent clerk. Anyway, Einstein, during World War II, he escaped from Germany because it was not a good time to be in Germany as a Jewish person. So he came away, he came to America, and he became a professor. He was already very famous then. He became a professor in research institute in Princeton, in the town of Princeton. Okay. I'm lucky that after I finished my PhD, I did my PhD in Princeton, and after I finished my PhD, I did research at the same institute where Einstein had been a professor. He had died already at that point. I started my PhD in 1985. Einstein, I think, passed away in the, can someone look up when Einstein passed away? I think it was in the 60s. Or was it 60s or 70s? I should be
1955.
1955. Yeah.
55. Okay. So actually 10 years after World War II ended. So yeah, so Einstein died 6 years before I was born. And I was born in 1961. He died in 1955. But when I went to Princeton, especially when after I finished my PhD and I went there, I met 4 different people who knew Albert Einstein, who, they were younger than him. And in one case, it was Einstein's friend's son. The famous Karl Schwarzschild, after whom the event horizon of a black hole is named, was Einstein's friend. His son, Martin Schwarzschild, was a professor at Princeton. He was a retired professor in Princeton when I joined. So he was 1 degree of separation for me, Albert Einstein. Lyman Spitzer was a second, Freeman Dyson, and John Wheeler. There were these 4 people I got to meet who were each 1 degree of separation from Albert Einstein. But I have another human connection that I want to make. I said that if a star is more than 1.44 times the mass of the sun, if it's more than that, it can't become a white dwarf, it becomes a neutron star. The person who made that first calculation, he was originally from India, the same country where I was born, but he was also my thesis advisor. He was my great-grand thesis advisor. Jim Gunn, Guido Munk, Chandrasekhar. So Jim Gunn was my thesis advisor. Guido Munk was Jim's advisor, and Guido Munk's advisor was Chandrasekhar. But I got the chance to meet Chandrasekhar. He came to Princeton. We got to spend an afternoon with him. He must have been 4 or 5 years after he got the Nobel Prize. He got the Nobel Prize for this discovery, this calculation. He made this calculation that got him the Nobel Prize. He made this calculation when he was in his 20s. He was a brilliant, absolutely brilliant person. Okay, I have said a lot of things. Do the children have questions?
Yes, Danielle.
What happened? What happened?
Can you hear him?
Yep, I can hear him.
Okay.
What happened if 2 galaxies
Meet.
meet?
Is there a chance that 2 galaxies can meet while they are moving in the space? So
Yes.
what would happen then?
I can show you a quick video if you like.
Yeah.
Yeah, thank you.
Let me do that. Just give me a moment. Just a moment. something is going wrong with my movies here. So just give me one more second. It's showing up very strangely. This is the video I want to show. I don't know why it's looking the way it is. Okay, so I'm going to show you a computer simulation and real images, actual snapshots of galaxy collisions. Okay, so I'm going to remove the label. I'm going to start the movie. Okay. Okay, these are two galaxies, but right before they meet, here are two pictures of real galaxies. The previous galaxies were computer models. These are real galaxies. So two galaxies are coming closer. These are computer models of galaxies. They are intersecting each other. You can see they're intersecting each other because, but stop. These are two real galaxies that are intersecting. Go back to the computer simulation. Each galaxy tears the other one apart, stretches them out. These are two real galaxies that are being stretched out. Each one is stretching the other one. And now you can see there, this is a computer simulation still, but we stop, change our viewing angle, and this is a real pair of galaxies. Okay.
Yeah.
Back to the,
And I ask,
this is what galaxy collisions look like.
What
Yeah.
if our galaxy smashes to another galaxy? What will happen to us?
What will happen? Nothing
will
bad.
it happen to us? They're worried now about what they saw.
No, don't worry. Don't worry. I'll tell you why you shouldn't worry, because when galaxies collide, they pass through each other. Stars go through each other. Stars don't smash into other stars. And planetary systems, like our solar system, will remain connected to the sun by the sun's gravity. It's nothing bad is going to happen to us. We will be part of a galaxy collision. We've already been part of previous galaxy collisions, and nothing bad has happened. By the time the next galaxy collision happens, the next big one is 5 or 7 billion years away. Nothing bad is going to happen in that galaxy collision, but well before that, the sun will become so big that it will burn the Earth. But again, nothing to worry about. We will die of other causes well before that. Because the sun will become bigger in about 5 billion years. 5 billion.
There's another question from Itai.
Yeah.
How much time does it take to do all this, the evolution?
Oh, for the two galaxies, that's a great question. Typically, one circle, one galaxy going around another galaxy, the typical time it takes is about a little less than 1 billion years. So, for example, the solar system takes 200 million years to go around the center of our galaxy once. But if you have a galaxy at a bigger distance from the center of our galaxy than our solar system, let's say 5 times further away, since galaxies have so-called flat rotation curves, the further out you go, the longer it takes to go around once. So when another galaxy comes and tries to go around our galaxy, it takes maybe 500 million years, maybe 1 billion years, depending on how far away it is. Do you know how long Mercury takes to go around the sun? I think it's 64 days. Earth takes 365 days. Pluto takes 243 years. So the further you get from the gravitational source, the longer it takes to go around. Same is true for galaxies. If another galaxy were to collide with us, depending on how close it came, that will determine how long it takes to go around.
They're asking if there are solar systems like us in the other galaxies.
Everywhere, everywhere.
And that
Anytime
means
we
there
look,
might be people there.
that we haven't detected yet, but there's no definite signs of life that we have found yet on other planets or around other stars, but there's definite signs of planets being present around other stars. This is a whole field of study called exoplanets, planets around other stars. What is going on here? My computer is behaving very strangely.
Oh, how to pay. They're asking if there is another. There are also solar systems around us. Will they be watching us like we're watching them?
I hope so. I hope we're interesting enough for other people to watch us, but we don't know. We honestly don't know. We certainly are species, and I would say probably other living species on Earth have a curiosity about our environment, what's around us. But it's hard to know if other, we don't even know about the existence of other living things. It's hard to know what interests them. One thing I'm intrigued by is if there are other living systems out there that are much smaller or much bigger than us, it may be hard for them to understand who we are or whether that we are another living species. Same for us, right? If there's another living species out there that's very, very small compared to like subatomic scale things, it would be very hard for us to recognize. Or if there was something on a galactic scale, very large compared to us, again, we would explain it in terms of their gravitational pull and all of that, but we wouldn't think of it as living. I think it's easier to recognize something as living when it's comparable in size to us.
Can we ask another question?
Please, please do, please. This is great.
Why stars fall like the Roman god?
Why do the stars that we know in our galaxy got the Roman names? Refer to gods, the Roman gods, like Pluto and Neptune and other.
Right. There are Roman names, there are Greek names as well, of course. Depending on which part of the world you live in, there are ancient names for stars all over the world. In different parts of Africa, in different parts of Asia, in different parts of Latin America, there are indigenous names for stars. The Greek and Roman names are, in a way, more recent names than the names people had for them before. The Greek civilization lasted for many years, so did the Roman civilization. So they established these names over other names that people call them. So there was some erasing of old names to put new names, because that made the emperors feel more important, that something is named after me now. They did this with our year. Right? I mean, for a long time, the year had 10 months in them. 10 months. Until Julius Caesar said, I'm so important, I need to have a month named after me. So the month July was made. And then after that, Augustus Caesar came along and said, I want a month named after me, and August was born. But if you think about it, the month September, sept, the word sept means 7. It used to be the 7th month. But with the addition of those 2 new months in the middle, it became the 9th month. Oct, for October, oct means 8. But it's the 10th month because those 2 extra months got added. Nov means 9. Dec means 10. So for September, October, November, and December, their names are meaningless now because of that rascal Julius Caesar and the other rascal Augustus Caesar who came after him. Right. So throughout history, people have felt very important about themselves and they wanted to name things after themselves. And that was true for stars and astronomy. It's true for months, true for all kinds of things, names of places, cities, Alexandria. You think about the name, Alexandria is named after, so there are lots of examples like that where names got erased, new names were assigned, But you're asking a very good question, which is why did people name gods? Why did they ascribe the names of gods to stars? I think there was a general belief that stars were beyond our control. They were bigger, more constant, and in some ways more powerful than us. They were beyond our power. And that's what you attribute often to God or some higher being, someone who is more powerful than you. So I don't know, I'm not a historian. But in fact, earlier today, Jamaica, just before my talk, Preston was talking about sort of art through the cosmos in art through the ages, and he was actually talking about something like this. Anyway, these are great questions, you guys. You're asking very, very good questions. I have my...
Excuse me, can I ask a question?
Yeah, please ask a question.
Can we see nebula? Can we please
Say
see
that again,
nebula?
please, louder.
Can we please see nebula?
You want to see a nebula? Of course. Let me see if I can show you a picture of a nebula. Can you see my screen now?
Yes.
So that red square is called the Carina Nebula. And we can zoom in and it looks like this. The color is red like this because what is happening is there are hydrogen atoms and electrons are jumping down from level 3 to level 2 to produce this red light. Should we zoom in some more? We can zoom into the part in the upper right. It looks like this. Isn't that beautiful? Should we zoom in some more?
Yes, yes.
So this top image is taken with a telescope in Chile, ground-based telescope on a mountaintop in Chile in South America. This middle picture is taken with the Hubble Space Telescope. The lowest picture is taken with James Webb. You've all heard of the James Webb Space Telescope. It's orbiting the Earth.
Yes, this is the news, right?
New telescope, exactly. It was launched on December 25th, 2021, Christmas Day.
Thank you.
Now, we can zoom in some more. I'll go back. You see this part over here, this rectangle? We're going to zoom into this part. Again, what you see from the ground, what you see from Hubble, what you see from James Webb.
وهيك بنشوفها من كل واحد من المواقع اللي حكينا عليها.
So, inside this thing that what looks like a thumb, right? It's like someone is holding up. Inside that, many solar systems are forming. Inside, many solar systems, not one, many solar systems are forming.
كثير معرفات شمس عمالين يتكونوا. متشابهين في الشعب بتوخى كان سريع هذا اتفق على السكن بدون الفرش وانا بحلف لما الدكتور كذا انا بضحك اذا بسمع صوت مثلا عم بحكي.
So in the top image, you can count 1, 2, 3, 4, maybe 10 stars. In the middle image, you can count 30 stars. And in the lower image, there's hundreds of stars. Because James Webb is so powerful. As a telescope, James Webb Space Telescope is so powerful.
I have a question. I can
Yes,
ask.
please. Yeah, please ask.
What's biggest galaxy?
What is the biggest galaxy? You know the picture we were seeing earlier, M87, and I said there's a supermassive black hole at the center. That's one of the biggest galaxies near us. It's called a giant elliptical galaxy, giant elliptical.
Thank you.
Thank you.
I can ask a question.
Yes, please ask a question.
There are different colors for different galaxies.
There are different colors for different stars and different galaxies. In fact, there are many things that produce color in the universe. Stars have different colors depending on their temperature. When you have a very low temperature star, you know, the color of the sun is about yellow, right? So equal mix of all colors of the rainbow. It looks yellowish white. But if you have a much lower temperature star, then it looks red. If you have a much higher temperature star, it looks blue. But that's not the only things that can produce color. There are other things that can produce color as well. It's important to know the temperature of a star will decide what color the star is.
Thank you.
Sure, thank you. That's a great question. Do you all know that some of your older brothers and sisters maybe, but certainly fellow residents of the village, they are trying to travel to Santa Cruz this summer to take part in the science internship program? I'll give you some of their names. Maybe you know them. Let's see. Bushra.
Bushra and Malak.
Abu Hamad.
Bushra, Abu Hamad, and Malak are coming, right?
Who's the second one?
Malak.
Malak Hasneen. Yes.
Sanin, yes, she's coming.
Then also Amir Haider. Nizar Jabarin.
Nizar Jabarin, yes. That's what I was telling them, that when they grow a little bit older, they can also join.
I really hope so. Really hope so. The others who are coming are Shiri. I think Shiri Marmur Cohen. Avishag. I think Avishag doesn't live in Neve Shalom. Shiri does. Who else? Tia doesn't live in Neve Shalom, right? She lives in East Jerusalem. Tia Abusnene. Her father used to
No,
be.
she's in East Jerusalem.
She's in East Jerusalem, yes. I think we have 8 children coming to the science internship program. I think 6 Palestinian children and right. We're very excited, really looking forward to their coming. We will learn so much from them about your part of the world, and hopefully they will also learn from other students and us about many things. I'm really looking forward to this. My fingers are crossed that they get their visas promptly.
Yes, we'll cross our fingers for them too.
Yeah, And next summer we will try to start, next spring we will try to start the process earlier, so there's more time.
Yes.
I'm
yes.
also hopeful.
And
I'm also-
good news are that they are negotiating about stopping this case of visa.
Oh, very good, very good. I'm also
I
hoping.
don't know when will that be, but it's in the process.
Okay, and they're working with the embassy in Jerusalem, right?
Yeah. Okay.
Yeah.
I have a question.
Yeah, please.
We have another question.
Of course.
Can you show a picture of Andromeda?
Of course, it's my favorite galaxy. I can show you many pictures of Andromeda. I want to show you a picture that I took with my colleagues.
Oh, look at this.
One moment.
Whoa. Look at this.
These are 4 pictures of Andromeda that I took. Not me alone, but with 3 of my students. This is the first digital mosaic of Andromeda.
Whoa.
And those are the names of the people who took the picture with me. Andreas, Phil, Shomak. My formal name starts with a P. That's why you see my name, my first initial as a P. But we took this picture 30 years ago, 1992. Yeah, 31 years ago. Do you know that these 4 are the same picture, just different contrast levels? This is also Andromeda. But I want to show you a movie of Andromeda. I have a nice movie of Andromeda.
Yes.
Okay. Okay. So this is Andromeda over here. Sorry, go ahead, Reem.
No, I didn't say anything.
Oh, no
Let's
problem. No
watch
problem.
it.
Okay.
That's nice.
So this is Andromeda. It is located 2.5 million light years away. Light takes 2.5 million years to reach us from Andromeda. That's Andromeda right there. It looks like a frisbee, right? Shaped like a disk. This big arc over here is our own Milky Way galaxy. But now what we're going to do is we're going to zoom in. Okay, I'm going to remove this label and we're going to zoom in. So watch what happens when we zoom in.
They're asking about our galaxy.
Oh yeah, okay.
Did we
So-
see the picture? Was it? Were you near? You were near it, right?
Yeah, I can show you a picture of our galaxy also.
Yes.
But these are stars in the Andromeda galaxy. This is a real image of stars in the Andromeda galaxy, taken with the Hubble telescope. If you want to see a picture of our galaxy, I can show you that. I have a movie of our galaxy. Should we go there next?
Yes, they would love to.
Yeah.
Okay. Just a
They were
moment.
so excited. I was on mute, but they wanted you to hear the oh of them.
That's wonderful. I have some pictures of our galaxy.
Whoa.
This is our galaxy. This vertical line is our galaxy. This is our galaxy.
This is our galaxy, guys. Listen.
Yeah. You see our galaxy over here? Oops, sorry. No, not that one.
Whoa.
This is our galaxy. That line across the bottom is our galaxy. but this is actually a
Whoa.
Whoa.
So do you know why our galaxy is moving like this across the sky? Do you know why?
No.
It's because we live on the Earth and the Earth is rotating. So this galaxy looks like it's going like that, but it's actually our own Earth that is rotating.
I know that.
Yeah, it's like if you've sat on a merry-go-round, you know, the merry-go-round you get that sometimes at a festival, you can sit in a merry-go-round. When you sit on a horse in the merry-go-round, it looks like the whole world is going around the opposite direction. So this is like that for us, right? Because the Earth is spinning, it looks like the whole Milky Way is sweeping. Let me show you another movie of the Milky Way. This is even better. This one shows you what happens if you take a camera and you make the camera rotate as the Milky Way rotates, okay? You can see the Earth's rotation.
Bye-bye.
Bye.
Here, Ron is saying that it looks like our world is going upside down.
Our world is going upside down, right? Our world is spinning every 24 hours. You can really see that in this.
Exactly.
Okay, it looks like you have to leave now.
Yeah.
This was so much fun.
If we knew that it's gonna be longer, we would have asked for longer time. But
Of
it's
course,
really
no.
interesting. I didn't believe I am going to be interested like this. Amazing,
Thank you,
amazing.
thank you.
Thank you very much for this opportunity. We
Oh,
really
thank you.
appreciate it. And
I
I'm
know
very
how
happy.
much- Yeah, I know how much hard work you put in to make this possible also. So thank you. And
Thank you
Jamaica, thank
very
you.
much.
Thank you.
Thank you.
Thank you.
Nice to meet you.
Bye.
Bye.